This video covers mainly the types of corrosion. Mainly I'll concentrate on the four category, that is differential metal corrosion, differential aeration corrosion, waterline corrosion and pitting corrosion. There are many more types of corrosion, but here I shall discuss only the four types of corrosion. Differential metal corrosion and types of it is also called as a galvanic corrosion. Okay, you can see one picture here. So before corrosion and after corrosion. So usually if this is the case, okay, then the metal undergo corrosion. What is that case? Here the two components, nut and bolt, are made up of a different metal. Okay, it is not the same. If it is a different metal, usually a differential metal corrosion setup. Like you know, the corrosion may take place due to the presence of two different metal or on the same metal. If two different metal is present, then again it depends upon the position of this metal in a galvanic series. The difference in the position of the two metal in the galvanic series is more than the anodic metal ions readily undergo corrosion. Okay, because the anode usually undergo corrosion. These are the few examples you can observe here. So here, this is a one metal like a steel, and this one is made up of usually iron. Okay, steel and iron. And here again we can observe a different kinds of steel, not same. Again the alloy also, the composition of this alloy difference or variation is observed. The corrosion also, the rate of corrosion of these metals also vary. Okay, here again we can observe these metals readily undergo corrosion, whereas this is less tendency to undergo corrosion. This one is a very good picture, so you can easily observe this one. So here the one is completely made up of iron, whereas this one is a steel. Okay, again the rate of corrosion if these two are different. Okay, say, and that type of corrosion, what we called it as a differential metal corrosion. When two dissimilar metals, not same metal, when two dissimilar metals are in contact with one another and exposed to a corrosive medium, then the metal with the lower electrode potential, becomes anode and suffer from the corrosion. Okay, that is a common thing. What is the reaction take place? Anode reaction is metal undergo corrosion, oxidation reaction, giving a number of electrons. Okay, and as soon as the metal ions are formed, that means liberation of electron take place. The medium may be acidic or a neutral. These electrons get consumed and liberation of hydrogen take place, or the absorption of oxygen take place. Okay, these are the possible reaction you already studied when the medium is acidic or a neutral. Hydrogen with the formation of the reaction may take place by the absorption of oxygen or by the liberation of hydrogen. This is a possible cathode reaction when that is take place by the liberation of hydrogen. The possible the cathode reaction when there is in the presence of oxygen. If you consider, that is O2 plus electron gives H2O. Further, this H2O help for the further reaction, oxidation reaction. Okay, or H2O, oxygen plus electron, usually 4 moles of electron forming 4 moles of hydroxyl ion. So, my God, whose mic is on and somebody's mic is on. ನಾನು ಹೆದ್ರಿ ಬಿಟ್ಟೆ. ಯಾರದು ನಂಗೆ ಎದುರಿಸಿದವರು ಆ ಲೆವೆಲ್ ಅಲ್ಲಿ? Okay. Liberation of, I'm not expecting that one, that's why. liberation, sorry, usually hydroxyl ion is formed at anode, and this hydroxyl ion combined with the metal ion, and the anode gets corroded. Okay, here actually we observe like both the metal undergo corrosion, but this metal, the corrosion if you observe, it is more compared to this, because this is some other metal compared to this one, nut and bolt. Okay, this is a good example for differential metal corrosion. Okay, whereas the metal with a higher electrode potential becomes cathode and protected from corrosion, and this type of corrosion is known as a differential metal corrosion or galvanic corrosion. The possible reaction during galvanic corrosion is metal gives electron, forming metal ion with the liberation of n number of electron. At cathode, the hydrogen, if the atmosphere contains high percentage of hydrogen, then liberation of hydrogen takes place. And sometimes if the medium is a neutral, then liberation of hydrogen takes place along with the formation of hydroxyl ion. If the medium contains high percentage of oxygen, then usually take place in the presence of oxygen by the absorption of oxygen, forming hydroxyl ion. These hydroxyl ions forming insoluble hydroxide, and further the undergo oxidation, forming oxidized product. They get added on, and as a result, the metal get deteriorated or it get destroyed. Okay, or decay of metal is observed. And this type of corrosion, what we call it as a galvanic corrosion. When two dissimilar, it is usually observed when, like, even in the protection of metals, we may introduce iron, we may couple iron with the metals like magnesium. And these two metals, if you observe, the magnesium act as an anode because of the two different metal. The metal with the lower electrode potential becomes anode and suffers corrosion, whereas with the higher electrode potential metal becomes a cathode and is protected. Even iron not undergo corrosion when it is coupled with the magnesium. The same principle is involved in one of the protective technique. In order to protect the iron metal, we connect the iron metal with the magnesium metal. As a result, a differential metal corrosion setup, magnesium undergo corrosion, thereby the iron gets protected. And this type of corrosion, what we called it as a differential metal corrosion, known as a differential metal corrosion or galvanic corrosion. These are the few examples what we seen in the picture, the galvanic corrosion that take place. Okay, so here the iron with the copper and here iron with the zinc. Among the two metal, which metal undergo ready or fast reaction? See here, if you observe, the iron act as in both the case, iron act as a corrosion. Iron act as an anode and undergo corrosion. In the two cases, the first case and the second case, in that the first case, the iron metal readily undergo corrosion because of the difference in the electrode potential of the two metal is large and has a more tendency to undergo corrosion. That is the same thing I given here. When zinc and copper metals are electrically connected and exposed to an electrolyte like hydroxyl, zinc metal as a higher in a galvanic series forms anode and suffers corrosion, whereas copper lower in, okay, this one is different things. Copper possesses a lower electrochemical, in an electrochemical series and act as a cathode, hence protected from corrosion. So here I'll take two different metal. One is zinc connected with iron and the other one is a iron connected with the copper. Here zinc usually it is minus 0.76, whereas iron is a minus 0.44. As a result, in this case, zinc acts as anode, whereas iron acts as a cathode, and thereby the iron gets protected. Okay. Whereas if copper, if you connected, the copper present in the lower position, and their potential is 0.34, whereas this one is minus 0.44. This acts as anode, whereas this one is, that means the metal may act as anode depending upon the other metal. Okay, whereas copper is lower in electrochemical series and forms cathode and is protected from corrosion. The extent of corrosion that depends upon the electrode potential of the two metals and also their relative area exposed in the metal, in the potential difference between the electrode is high, then greater is the corrosion rate. Okay. So in the first example, brass tap fixed in an iron pipe, and this one brass tap, whereas it is fixed in an iron, and even some picture the steel screws in a brass marine hardware. So we observe these are the good example for this. And again, the corrosion that depends upon the relative positions. So this iron metal, when you connect with the metal like copper and silver. Okay, so iron readily undergo corrosion when it is connected with the silver. The difference in the electrode potential of the two metals that decides the rate of reaction. Also, it relative area exposed to this environment. So, because the difference in these two is less, this is 0.344 with that of minus 0.44, the difference is less compared to 0.8. So, as the difference is more, the rate of this, the corrosion rate of the anode metal ion becomes more. So, this is all the things comes under differential metal corrosion. Okay. So, any doubt, students, under differential metal corrosion? Differential metal corrosion. It is just like introduce the two different metal. The metal with a lower electrode potential, they act as anode and undergo corrosion. Okay. The metal with a higher electrode potential act as cathode and it is unreactive. Okay. Also, it decides the difference in the position of the metal in the electrochemical series. Higher the difference as well as the higher the relative area exposed to the atmosphere, then the rate of corrosion usually high. Okay. And I give one example. The same metal, one metal may act as a anode in one atmospheric condition. The same metal may act as cathode in another atmospheric condition if two different metals are connected to this metal. Like iron, if you connect it with the copper and the zinc, in one case iron act as a cathode, in another case it act as a anode. Okay. Differential aeration corrosion. Okay. So differential aeration corrosion that occurs when a metal surface is exposed to a different air concentration. Like you already studied, in a concentration cell, same metal present in a two different concentration environment. Here, if you consider a metal like iron, okay, it may be present in the two different environment. Particularly, it may present at one portion of the metal is exposed to a more oxygen compared to other portion. Like say I'll take one metal like zinc or iron metal. If you dip it in a water, okay, so the portion of this below water, so they usually oxygenated, less oxygenated, whereas this one is exposed to the atmospheric oxygen. So there is a variation in the oxygen concentration cell. Okay. Or sorry, there is a variation in the oxygen concentration. As a result, there is a setup of a cell due to difference in the air concentration. So the one part which exposed to a less oxygen usually act as anode. The reason you know already. In the concentration cell, so the lower concentration part act as a anode. Similar way here, the portion which is exposed to a less oxygen usually act as anode, whereas a more oxygenated part act as cathode. Okay, and that type of corrosion, what we called it as a differential aeration corrosion. The differential aeration corrosion occurs when a metal surface is exposed to different or differential air concentration or oxygen concentration. That is a one part of the metal exposed to more oxygen concentration than the other part. Okay. So here, if you consider a metal which is exposed to the atmosphere, in that over that metal, if a drop of water or a sand or a mud particle they exist, then the area below this air portion usually corroded. The reason is, and this area is less oxygenated, whereas this is a more oxygenated part. And the less oxygenated part act as anode. Usually under corrosion, the anode undergo oxidation, so get corroded. The part of the metal which is exposed to higher oxygen concentration usually act as cathode, and the part of the metal which is exposed to lower oxygen concentration act as anode. And the poorly oxygenated region usually undergo corrosion. And this kind of corrosion, what we called it as differential aeration corrosion. That is the one part of the metal exposed to a more air concentration than the other part. Okay, and that's why this particularly depends upon the air concentration. That's why the type of corrosion, what we called it as a differential aeration corrosion. So on the same metal, this type of corrosion take place. Like anode reaction in the less oxygenated site act as a anode and undergo corrosion. That is, a metal is lost in the form of metal ion. Okay, and the more oxygenated part, and this part usually undergo cathode reaction. That is, a more oxygenated part in the presence of moisture takes electron and forming some negative ion like a hydroxyl ion. And again, the further things, the in between the positive and the negative ion, insoluble components are formed. Okay, the corrosion of metal arising as a result of formation of oxygen concentration. Here the concentration cell itself, it is a oxygen concentration. Due to variation in the concentration of oxygen, a cell is set up. So that's why it is called as a oxygen concentration cell due to the uneven supply of air on the metal surface. That is known as a differential aeration corrosion. The good example for differential aeration corrosion is windows rod. Inside the frame usually suffers corrosion because in the case of windows rod, so inside the frame means the area which is exposed. This, if you consider this is a wall, so the certain area it is exposed to the atmospheric, this area is usually exposed to the atmospheric content, whereas the other area is exposed to the wall. So this is usually a less oxygenated. If any small gap is present, then it is a less oxygenated. In that area, act as anode and undergo corrosion. Another simple example is this one, paper pin. You may be observed, you may be seen the last semester certain notebook, if it is a pin, or like a Xerox copy, it is usually stapled there. So if you take out and just see that one, below that the pin which is below part that is exposed to the paper side, they usually undergo corrosion or some red colored deposition is observed because usually the pins are made up of steel. So it get corroded because that region is exposed to lower oxygen concentration, whereas the other portion that is exposed to the higher oxygen concentration and act as anode. Okay, the exposed part is free from corrosion. This is a good example. And the other one is an oil tank or a water tank or a pipeline buried under earth. They gets corroded due to lack of oxygen. Like in this case, the pillar. So it is under the earth. So in this region, particularly in this region, gets corroded because variation in the oxygen is observed, whereas the above portion, it is completely exposed to atmospheric oxygen, whereas this region is a small certain portion is exposed to atmospheric oxygen, whereas this region exposed to the it's not exposed to the atmospheric oxygen, or it is a less oxygenated site. As a result, variation in the oxygen concentration, so a oxygen concentration cell is set up, or in other words, the metal or exposed to a lower oxygen concentration act as anode and undergo corrosion. Or you can observe clearly here even the same metals, the two metals, some region is exposed to the atmosphere, this region, whereas this region is exposed to another metal, whereas here there may be some deposition of moisture are possible and it is exposed to the atmospheric, also less oxygenation. So as a result, corrosion take place. And this type of corrosion, what we called it as a differential aeration corrosion. That is, a corrosion occurs when a metal surface is exposed to a differential air concentration or oxygen concentrated than the other part. The part of the metal which is exposed to higher oxygen concentration act as anode, and the part of the metal which is exposed to a lower oxygen concentration act as cathode. And here the definition of differential aeration corrosion can be stated like this. It is due to the formation of oxygen concentration cell, that is due to the uneven supply of air on the metal surface. Okay, this is a second kind of corrosion. And the third kind of, and this is a one example, like zinc rod, if you dip in a dilute solution or even a neutral salt solution, so anode and cathode part we can clearly see here. So here I just take a zinc rod and dip in a dilute solution like a sodium chloride solution. I just introduce a sodium chloride solution. Okay, here the portion which is exposed to the water, it is usually come in contact with the dissolved oxygen. So it is a less oxygenated part. Whereas the portion which is exposed to the atmosphere, it is a more oxygenated part, act as cathode. And here at anode, the less oxygenated part, the time the metal is decay or it dissolved in the form of metal ion and liberates electron. Usually this liberated electron move towards cathode, whereas the cathode is a more oxygenated part and it acts as it helps for the reduction reaction. So the hydroxyl ion is formed somewhere. The hydroxyl ion combined with zinc and the corrosion product is formed and they get deposited at anode site. Okay, the immersed parts gets less oxygenated and act as anode. This is an example for differential aeration corrosion. And the third type of corrosion is a case of differential aeration corrosion. You can see this type of corrosion like in the case of ocean going ship or even a steel water tank, or like this in the bridge you may be observed while constructing a bridge we may use some iron pipes or what pillars. Okay, and the area in these area, particularly the change in the concentration of air. Okay, that is the pillar which is inside the water. They usually suffers corrosion. The reason is, so inside the water it is a less oxygenated site or only dissolved oxygen present. Dissolved oxygen. Whereas this is exposed to the atmospheric oxygen. Whereas even in case of ocean going ship, you can observe some like ring-like component here, the brown color ring-like component. Here, particularly the difference in this particular region, the difference in the oxygen concentration is observed. Whereas the below part is completely exposed to the dissolved oxygen, whereas the above part is completely exposed to the atmospheric oxygen. Whereas in that particular range, change in the concentration of oxygen is observed. As a result, a waterline corrosion is developed. Okay, and the third category of corrosion, what we called it as a waterline corrosion. It is a type of differential aeration corrosion. It is particularly observed in a steel or iron water tank or ocean going ships. It is generally found that the maximum amount of corrosion takes place along a line just below the water level. Okay, not complete portion of the metal is not corroded. In particular region where the change in the concentration of oxygen is observed, that is a particular region where the portion is immersed in water and that particular region or the boundary where the corrosion take place, because the variation in the concentration of oxygen is completely observed, whereas the other portion is either it completely exposed to the atmospheric oxygen or it completely exposed to the this oxygen, completely exposed to the dissolved oxygen. Say in case of part of the tank just below the water level is exposed to lower oxygen concentration, that you know, that is dissolved oxygen become anodic because it is a less oxygenated site, act as anodic. But the complete anode part is not undergo corrosion because the same concentration is observed, but just below the water line. Here, just below the water line, a brown colored ring is developed or the rust component that get deposited just below the water line. The part of the tank above the water line, which is exposed to higher oxygen concentration and becomes cathodic. Okay, and the reaction is same. Anode, the loss of metal is observed and the electron is liberated. They move towards cathode and some negative ions are formed, and that negative ions combine with the positive ion. A distinct brown line is formed just below the water line. So that's why this type of corrosion, what we called it as a waterline corrosion, and they categorized into a different way. It is particularly observed in an ocean going ship and the water storage tank or any component which is immersed in a water. Okay, that is the portion which is immersed in the water just below that water line. It is always exposed to the dissolved oxygen, less oxygenated site, whereas the other portion is exposed to a more oxygenated site. So as a result, just below the water line, we observe a brown line just formed just below the water line. And this type of corrosion, what we called it as a waterline corrosion, observed in a water storage, steel tanks, and even in a ship. Okay, this is a one type of differential aeration corrosion, like in the case of this pillar even, and even in the case of ocean going ship. But the slight corrosion take place in the beginning. If you observe a distinct brown line, we can clearly observe just below the water line, not complete part rusted. In the beginning part, if you observe in the beginning of that corrosion, just below the water line, you can observe a distinct brown line. And this pitting corrosion, it is another kind of corrosion. It is also a differential aeration corrosion that is formed due to the pit or a small hole that are corrected. But it is a most destructive form of corrosion. A sudden failure in the equipments are observed. So these are some industrial equipments where the boiler, in that case, we normally observe this type of corrosion. Here we can observe small pits, that is a crevice or small holes, cavities are formed. So through which a difference, we can observe like a salt component, they migrates. As a result, the concentration of salt increases. When they reach a certain concentration, they may attack the metal. Okay, as a result, the corrosion take place. And that type of corrosion, what we call it as, if it is included stress, then it is called as a stress corrosion. Without stress, if this type of happens, then it is called it as a pitting corrosion. Okay, the pitting corrosion is a most destructive form of corrosion. We can observe the pictorial representation. So due to some reason, some small pits, or even during manufacturing time itself, some pits or pinholes or a cavity is exerted in the metal. That time, if it is continuously exposed to the atmosphere, then the oxygen in that area, usually it is less compared. In this area, it is less oxygenated, whereas the other area is a more oxygenated area. This less oxygenated area usually is lost, the metal is lost in the form of metal ion, and it liberates electron, and this liberated electron migrate towards cathode, and the cathode, some negative ions are formed. That is a more oxygenated part, and these negative ions, they attacks the or combine with the positive ions, and as a result, corrosion begins. So the pitting corrosion is a localized or accelerated type of differential aeration corrosion. This is also a type of differential aeration corrosion which results in the formation of small pits, pinholes, around which the metals are relatively unattacked, or around which the metals, if you observe, it is clear, it is there is no rest or the deposition is observed. Okay, whereas in the particular area, pits or pinholes, it is attacked by the environmental constituents, or because of less oxygenated part act as anode, and its metal is lost in the form of metal ion and combined with the negative ion. So pitting is one of the most destructive form of corrosion. It causes sudden failure of the equipment, that you know. If you observe the outer part of the material, so it's we are not observe, or it's not possible to predict whether that equipment is in a right condition or not. So because even the small holes or pits are present, so that pits help to produce a corrosion products, and the growth of the pits is observed, and they may enter in the inner surface. So it is characterized by a small anodic and the large cathodic area, resulting in an accelerated corrosion. This is the one factor that decides the corrosion rate. Smaller the anode, larger the cathode, result in a fast corrosion. As a result, a destructive corrosion or the fast corrosion takes place, and within a certain period, the sudden failure of that equipment is observed. The pits, how these pits are formed, that may be during manufacturing time itself, or maybe due to breakdown of protective film. Sometimes, in order to protect a metal, we may introduce other metal over this. Since this the protective metal, if the breaking of this protective metal is observed, again the differential metal corrosion is observed, and the continuous pitting or pinhole is created. Once the pinhole is created, then localized attack takes place and differential aeration set up, so the sudden failure of the equipment is observed. The pitting corrosion is also caused by the breakdown of protective film on a metal surface, results in the formation of small anodic area, leaving behind a large cathodic area. Okay, So this pitting corrosion is a localized accelerated type of corrosion, differential aeration corrosion, which results in the formation of small pits, pinhole, around which the metals are relatively unattacked. And it is a destructive form of corrosion, and it is particularly characterized by a formation of small anode and large cathode, resulting accelerated corrosion at anode part, creating a small pinhole or pits on the surface of the metal, whereas the around the area, the relative area is completely it is unattacked. So it is so that the sudden failure of the equipment is observed. Okay, the pitting is generally initiated by the deposition, or other cases it may be due to the deposition of extraneous matter. A small deposition over the surface of the metal also results the pit or a pinhole creation. Okay, the metal below the deposit, it is a lower oxygen act as anode and corrosion takes place. And if it is accelerated due to the formation of small anode, large cathode, so that pits or pinholes are created. There are different types of pits or pinholes are observed, and based on that, we can categorize it like a horizontal pitting, vertical pittings, narrow pitting, deep pitting, like they're not needed. So you just consider, or you take into consideration of what is pitting, how it is formed, and you can take some example for pitting corrosion. So these are the some examples, like a sudden breakdown of the equipments or machines, or here it is again. So you can observe this area is relatively good compared to this. So but here the sudden pitting or the sudden breakdown of the component is observed. And here also, so this area is remains same, but here it creates a pin or a pit or a pitting corrosion. As a result, a sudden failure of the equipment is observed. Okay, here